Hey folks, Cool18 here, and welcome to another Unity 3D Quickie. This is not really meant to be a tutorial. It's mostly I wrote some code and I want to show it to you, and you can use this as like semi-documentation or something like that. It's definitely not guaranteed to be good, but it's maybe meant to be a starting point for something. So I'm partially putting these up because a game jam is coming up and some people might want to use the code. So here I've made a relatively simple car setup. And one of the things that people in Unity, when they've gone and tried to make these car simulators, they found out a few things. First of all, the built-in physics system is not great at really simulating a car in terms of tire physics and things like that, which are a relatively complex kind of thing. First of all, just for reasonable sort of collision and rolling kind of physics, you probably have to set the physics engine to such a high tick rate for accuracy that your CPU would explode. And secondly, the objects in Unity are really very solid object, and cars, when you take off in a car, and especially a fast car, right? If you just put the pedal to the metal, full speed ahead, give it full throttle, and the car starts to go, right? You get the tires squeal, right? As you start off, you can burn rubber. Well, what actually happens when you first take off in the car, the rubber is, basically sticking to the ground, right? You got friction there, it's sticking to the ground. And when you first start to take off, the rubber actually like bends a little. There's actually some give to the rubber. And then at some point it loses its proper friction to the ground, its contact to the ground, at which point it starts to spin. The same thing happens in corners. When you go into a corner, it's stuck to the road, but if you go too fast, then again, you can start to skid and slide at that point. And so that physics, that's a friction system, is something that the built-in Unity engine is not really designed to simulate. And so that's why you end up, there's a special kind of collider called a wheel collider. It works differently. It it sort of almost cheats or simulates things in a way that the rest of the physics system doesn't do. But it is a pretty good approximation of how tires would work in the real world. It's still not perfect. If you want to make a super high quality racing simulator that's mega accurate, you'll probably want to write all your code from scratch for that. But for something like this, which is, I sort of made kind of a toy box kind of thing, and I actually made this car work more like a remote control car. Oh, there we go. Than anything else. It's pretty good. This car has no gears, just one gear, and it's pretty forgiving to a lot of things. So that's the first thing that you find out when you try to make car stuff in Unity is the normal physics colliders and rigid bodies aren't up to the job. You have to use wheel colliders. The other thing you'll discover is as you make your first car and you get it going, it wants to flip over right away. Like you're effectively doing something like 30 kilometers an hour here, and you hit left, your car will flip over. You'd be like, what the hell? That makes no sense. Well, the problem is cars basically want to do that in real life. And there's a few things that are working together to stop that from happening. The first thing you'll note is, and again, of course, all the graphics in here are just goofball things. I have like basic little particle effects in here to try to simulate skidding, for example, just for demonstration purposes. In Unity, by default, your wheel colliders have they're very sticky. Oh no, I'm off the map. No, all right, I'm safe. The wheel colliders are very sticky. They don't want to skid at all. And so what happens is as you go into a car, and everyone who's ever driven like a van or something like that, or, a pickup truck or something, when you go into a corner, the car sort of tips over some. Well, if your wheels are perfectly sticky, then when you go into one of these sharp corners, there's no give, and the only thing that can happen is your car flips over. What you want to do is you actually want to reduce the friction, reduce the traction in Unity so that when you go into a corner, there's a little bit of skid that goes on. So some of the sideways force, or some of your turning force gets converted into a sideways slipping force instead of having to go right into a roll. But the other thing that really happens, and so that's step number one. But if ever you've driven a really fast remote control car, and I've got a gas-powered remote control car, which is kind of fun to play with. And if you've ever done it, you'll know if you're going sort of in a straight line at your max speed, and then you turn even a slight little tap to the left or to the right, your whole car will flip over. That's actually realistic. Your remote control car will flip over all the time. Don't get attached to your paint job at all. And the reason real cars don't do it as much, I mean, partially it's the weight, and partially it's better suspension setup, which we'll have to talk about here. But real cars actually have anti-roll bars, which effectively transfer force from one side of the car to the other to try to counter these rolls from one side to the other. And really advanced cars with super computerized suspension, the computers will be calculating these forces. So in an anti-roll bar is an actual like mechanical thing, and in electronic computer-controlled situations, your computer can adjust your suspension settings on both sides to sort of stiffen and weaken suspensions in response to a roll to cancel out rolls and things like that. So this car setup here has A, friction settings that are set up to try to be a little bit more reasonable. B, a suspension setting that's ideally a little bit more generous. C, has a bit of an artificial center of gravity to try to prevent flipping. Now that doesn't really prevent that much in the way of rolling. It's mostly for things like this, where you kind of go into a roll. Well, it's going to try to right your car all the time by virtue of the fact that the center of the gravity of the car is actually underneath the car itself. And then finally, it does have a script that simulates anti-roll bars, which is a very simple script that's actually from the internet. You can do a Google for Unity anti-roll bars, and you'll find many, many references to this script. It's a very, very simple. It's like 4 lines, basically, to get this working. But in the end, you get this thing. Things to note, this car simulation script that I have here has no gears whatsoever. It's a single gear thing. It's mostly simulating almost like a remote control car than anything else. It does try to simulate the fact that vehicles have an ideal RPM where they get the most power at a certain RPM range and also a maximum RPM. In this simulation, it's not based on the engine RPM, it's the actual wheel RPM directly happening. So it's almost like, we had the gearbox. There's no gearbox. The engine is directly connected to the wheels, which is of course not entirely realistic. What else? I thought there was one more thing, but I can't remember what that is. Yeah, I'm sure we'll run into it when we get into the script. So there are 2 major scripts to talk about on this car. First, I guess we'll talk about how the game object is actually laid out. Note, I've got 3 variants here. I've got like my first take of the car, and then another one where I really tune the skid to be a little bit better. And then I have another one with softened suspension. Actually, I can disable the decent skid one and enable the softened suspension. And if we hit play, you'll see this one, especially if I don't maximize it, you'll see this one is a lot more like a monster truck or something. It's raised up quite a bit. And if I hit the gas, it'll actually like roll back quite a bit there. And it'll be relatively soft as it goes over here, which may or may not be better. Well, that's a bad example because I almost flipped over here. Okay, let's try that again. And so it's quite wobbly and bumpy and works better for like low speed but rough terrain. So anyway, they're just tuned to slightly different behaviors. We'll leave the decent skid version on there. So if we look at the object itself has simply a rigid body and the car controller script, which is what's going to be included in this package. Inside of that, first of all, it's got these 2 cubes that simulate the body. Now, it should be noted, these don't really have to exist. If I disable these, well, I'll still get sort of the tires, but we're still working. The big deal is if there was like a pole, we'd now be able to go directly through the pole. We wouldn't actually like hit anything there. So if you go into your modeling software and you model a proper car graphic, you're basically going to want to replace these 2 cubes and drop in your actual mesh of your proper car in there. I've got a couple of headlights turned on just for visual effects. I put the main camera inside of the car, so that way, it's the cheapest, easiest way to have the camera follow the car around. And also what's neat is if I accelerate, you can actually see the camera sort of tilts back because the whole car body does. And if I hit the brakes, it sort of faces down into the ground just a little bit. And, I don't know, it gives it a really good sense of motion because that's sort of what your body would be doing in the car itself. And then it's got the 4 wheels. Now it's worth noting, these objects here, all they're made up of is a wheel collider. And they also have the particle system. The particle system is there to sort of simulate the you're skidding when you go. It's just there to show when your car is in a skid or a slide. That's the only reason it's there, and it's not particularly realistic. So that's it. It's just got the transform and a wheel collider. And if we look at the wheel collider, you can see it's a green circle and then a line underneath it. That is literally the entire thing. Inside of this wheel, I have this thing called tire, which is the actual mesh that you can see. Now, it's worth noting, I can turn off this tire. This tire graphic, I can turn that off, and the car will work perfectly fine. Everything is fine because it's this wheel here. Let me hit the brakes. It's this wheel here that determines where the car is on the ground, how the physics work. You'll note the circle never moves. So even though it's technically touching down here, the circle effect doesn't move, and it's part of this line and the suspension and things like that that has an effect on stuff. I could turn this graphic back on, and what I could do, it's got the script here I call tire to wheel. If I turn that off, oops. If I turn that off, turn this on, and then hit play again, you'll see some odd behavior here. The tire is no longer touching the ground, and if I steer left and right, this tire no longer turns. And the reason is, again, this wheel collider, which handles all the physics, has no visual representation and doesn't actually turn. It's quite obvious if I go to the top view over here. Actually, I'll use the other tire here as an example. Go to the top view over here, even though I turn the tire, actually the green line does turn. I didn't realize that the green line does actually visually turn. Never mind, but it doesn't go up and down. My tire goes up and down. The black cylinder goes up and down, but the green line does not. And so the reason for that is, well, we'll talk about that, but basically the wheel collider is just a simulator. And so what you have to do for your actual visual tire over here, you need a script on it, and this script is responsible for moving this visual mesh to meet what is being simulated. And so I'm not going to go into that script too much because partially one of it is determine, this is the bit that determines if we're skidding and then turns the particle systems on and off. But mostly what it's doing is it's got this line here, which is responsible for moving the tire up and down. Actually, it's these two lines over here. They're responsible for moving the tire graphic up and down based on where it's sort of the suspension is. And then there's this line over here, which is responsible for rotating the tire graphic to equal the angle that the wheel collider is turned at. And that's all there is to it. The real script is inside this car collider. And so it could be much, much simpler than this if we wanted. There's a lot of things you could strip out. But again, if you really want to avoid too many situations where your car is kind of flipping over, you need a fair deal of these features in here. It's not a terribly long script, and a lot of it is, duplicated lines, but let's go through it. I realize there's not much in the way of comments. Maybe I'll try to add some in before I upload this online. But we do simulate this idea that there's an ideal RPM. This is the RPM, again, of the tires, or you can think of it as the engine is directly connected to the wheel. There's no transmission. So this is the rate at which we get the absolute max torque out of our engine. And this is the absolute maximum. When we reach this RPM, our engine will be adding 0 torque to our tires, and therefore we can't go any faster than that. You can actually map this RPM, because this is the wheel RPM. This will actually directly tell you what your maximum speed is, because this is how fast your wheels will be turning. Your wheels have a certain radius, and so if you multiply the radius by pi by your RPM, that'll give you your speed, basically. And it's incidentally, that's how I actually calculate what my speed is I figure out my current RPM, multiply it by pi, multiply it by the wheel radius, and because this is in rotations per minute, and this is in meters, I multiply it by 60 to get per hour, divide by 1,000 to get kilometers. So this is how I get kilometers per hour based on those numbers. Okay, so these are a bunch of things that are exposed in the inspector. And if we go to our actual base car over here, we can see them. Our ideal RPM, I actually have it set down to 50 because of reasons. If I set it back to 500, again, it would make a lot more sense if we had actual gears. If I set it to 500, I think we'll still mostly be okay. You see, I think it starts a little bit slower. I had it set down to 50 so that I could get really good speed right off the line. But by tuning it to about 500, you get less of that skidding effect, and instead you get a better sort of midline speed. And the top speed is basically based on this max RPM. If I were to drop this to, say, 800, you'll see our top speed will change in accordance with that. Again, the collider, I think I'm using 0.6 as the radius of my tires. So there's a direct relationship between the max RPM times 0.6 and what we get as our max speed there. Because once we hit that speed, we can't accelerate anymore. So I'll go back and put it in 1100. I've got the center of gravity here. This is one of the things that you use to sort of fudge the rolling system. Now, by default, if we didn't set a center of gravity, the rigid body component right over here will use all your colliders and we'll figure out a midpoint for your center of gravity, which would end up being around here where our transform is. And that's not really realistic. Actually, it might even be a little bit higher than that. And that's not really realistic because a lot of the top part of a car is empty. Most of the weight is at the bottom of the car, and specifically towards the front where the engine is. So you got all your axles and everything like that near the bottom of the car, and those are really, really heavy. So your center of gravity is probably around here in a car. Now, I've went and put it even lower than that. So I've got this transform, and I link to it. And I set this transform where I want the center of the gravity to be. And I put it below the car. That way, as the car is sort of flipping through the air, it'll have a tendency of righting itself. In fact, if it rolls onto its back, it's very likely to flip over to its stomach if it's got any sort of momentum left to it. And that makes it just a little bit more arcadey. If you wanted something a little bit more realistic, you know, maybe put it around here, but I'm going to go ahead and leave it there just because it makes it go a little bit better. Other variables in here. So the ideal and max RPM, the center of gravity. I need a reference to all my wheel colliders. So I just, you know, made those public and then dragged them in. The turn radius controls if I hit full right on my keyboard or my controller, how many degrees turn is that? And right now I have it set to 10 degrees. You can get sharper turns. If we set it to something like 25, I could get sharper turns. But whether that's a good idea or not depends on your speed and skid and stuff like that. Like, those are pretty sharp turns. Maybe that's ideal. You're more likely to flip over, of course, or lose control of the car. Oof. But, you know, maybe that's what you want. I don't know. I'm going to go ahead and leave it at 10. The torque, so that's the maximum torque that can be applied. This is if I'm hitting full forward, ignoring the RPM stuff. Hitting full forward, that's how much torque would be added to my tire. So let's go ahead. Let me comment out a bit. This right here is where we scale the torque based on our ideal and maximum RPM. If I get rid of that, no matter what speed I'm going, the same amount of torque will be applied to my tires, which will basically accelerate me at the same rate. And I'll have no maximum speed. I can keep accelerating, hit 200, 300. Well, now that I'm in midair and there's like literally no resistance, I can spin the tires faster and faster and faster. My speed is just calculated based on how quick my tires are spinning, not my actual speed through the air. So there's no limit to how fast I can go, which is probably not quite right. Now, there's a bunch of different ways that you could limit things, but just applying the torque directly there. And because of how all my suspension is tuned, I'm going to say there's almost going to be impossible for me to corner without flipping myself over here. Oof. Yeah. So you have to, you know, you're going to have to retune your physics sort of based on your speeds, which is exactly the same thing that happens in car design. You know, your suspension and anti-roll systems that you have in a Bugatti Veyron is very, very different than what you might have in a Dodge Caravan, for example. So anyway, and again, this is without a gearing system. With an actual gearing system, this code here would be somewhat more complex, as you would be checking the current gear, what your engine's ideal and maximum RPM is, and then multiplying that out by your current gear, your current speed, all kinds of different things like that. You probably have it farmed out to a function. But yeah, so in our fixed update, if we go through here, because what else? Did I forget anything else in the inspector? The anti-roll, we'll talk about that. Oh, the drive mode, I have it set up. You can have front wheel drive, rear wheel drive, or all wheel drive. You can tell if I go to a rear wheel drive and I accelerate, you'll only see the smoke coming out of the back tires. Right there. You can see that it becomes more obvious again. If I take my ideal RPM and drop it down to something ridiculous like 50, then we'll get a lot more skidding right off the bat because we're getting more power in there. There we go. So you can see it's only coming out of the rear tires. And yeah, the anti-roll, and then, my speed text over here. So if we look at the actual code, you can see this is where I set the center of mass based on my that center of gravity transform that I passed to the script. I set the rigid body center of mass there, and then we forget about it. A couple of functions that return my current speed, my current RPM, and again, that's based on the wheel RPM, not the engine. You know, a lot of engines would have a max RPM of, I don't know, 6,500 maybe even more if it was like a Formula One car or something crazy like that. And the fixed update is where all the real work happens. We update the speed text. The torque is based on the vertical axis, so up and down on the keyboard or the joystick, multiplied by my my torque value, which is right now it's what, 500, right? So we get that scaled torque. So it can be 0, it can be positive, it can be negative if I'm holding backwards, in which case we'll actually, you know, reverse. And then I do my sort of wheel RPM calculations. This is not realistic and really need to be tuned a lot, but the idea is, especially if we look at this one, this is when our wheel RPM is greater than our ideal RPM. The higher it is, the more we get close to our max. So once we get to our max RPM, this will equal 1. If we're at our ideal RPM, this would equal 0. So if we're at our ideal RPM, which is 0, this lerp will simply return the scaled torque, which means we'll get maximum torque. If we're at our max RPM, which means this will return 1, which will mean this lerp will return the second number, which is 0, means our torque will be 0. When we're at our max RPM, we apply 0 torque to our wheels, because our engine is sort of like redline. It's spinning as fast as it can. It can't spin any faster, which means we don't get any extra juice to the tires at that point. So that's all that does. I'll talk about the roll bar code in just a second here. If I do turn that off, it'll be a lot easier to flip our car. Because of our suspension and traction settings, it won't roll quite as easy as it would right out of the box, but it'll still be pretty flippy overy. Here's our steering. We just take our horizontal axis, multiply it by a turn radius. That's how our steering gets applied to our front and rear, or our right and left front tires. Note, we could have one of those cars that turns on all 4 wheels very easily by doing that. And then I guess you would do a negative on the back. Let's try that. Actually, that'd be kind of cool. Now if I turn, you can see all 4 wheels kind of turn, and you can do, probably just much tighter turns, depending on the kind of car you're trying to make, but we're not trying to make that kind of car. Here we apply the motor torque, like our scaled torque, we apply it to a wheel motor. Effectively, the way the simulator works is every wheel has a motor. And here I'm just doing a check. If we're in rear drive mode, then we apply nothing to the front wheels. If we're in front drive mode, then we apply nothing to the rear wheels. Otherwise, they get applied the torque. And then if we're pushing down the fire button, which is, I think the space bar by default. No, I think it's left control by default, or the A button on the Xbox 360 controller, which is what I'm using. Then we actually apply brakes. Here's the roll bar code, and there's a lot of like little mathy things, but the gist of it is, if we're touching the ground, then we figure out where the suspension is, like how deep, how compressed the suspension is on both sides, the left tire and the right tire. We check how compressed the suspension is. We figure out the difference between the two and multiply it by an anti-roll value. So if our right one is more compressed, then we will end up having a negative value. And if the left one is more compressed, this will come out to a positive value. And then we apply that force to both tires that are grounded. And it tries to stop the roll by just inverting the roll behavior. And this does a relatively good job of simulating how anti-roll bars might work in real life. And anyway, all that's how you get a car that doesn't... Oh, did I not... Oh, I probably didn't save the changes. I was like, why are my rear wheels still being goofy? There we go. So yeah, so now we've got this sort of very, very, very arcadey car system. And if you want to make a more realistic car game, then you're definitely going to need to do some gearing stuff and probably fine-tune the suspension like crazy. The other thing to consider with things like the suspension and the anti-roll strength, consider that being something that you might want to expose to the final player. If they bring their car into the shop, maybe they can tune their own suspension parameters and find something that's better for their particular challenges. Maybe you have different racetracks. Some are totally flat. Some are really bumpy. Some are wet. Some have much, much tighter corners. And so all those things indicate that you might want a slightly different performance in your various numbers. How come I can't? Oh, there we go. Because I don't have a proper gearing system, if your speed does go into negative, it really, really crushes the ability to accelerate forward. It's like being in a very, very high gear, which is sort of what this is. This is, I don't know, when you try to make something that does it all, low speeds, high speeds, you end up something that's not very good anyway. But there you are. If you do want to see another script that adds some more details, especially one of the examples of gearing, check out JCar. Google JCar Unity online. It's a decent car script that actually does some pretty nifty stuff with gear ideas, and it duplicates a lot of the things that I've done as well. Basically, the stuff in this script, none of it is revolutionary. It's all based on standard techniques that everyone is using for their car games. I'm trying to flip the car. It's actually really hard, even applying full brakes and then hitting full left or right. I guess what I could do is rock it one way first. I'm going to try to see if I can flip it here. Go up to my maximum speed in this car. Full left, and then right with the brake. Nope, can't do it. Well, that's some pretty good anti-skid, which may or may not be realistic. But again, if I go and just let myself go a little bit faster, then I can easily flip. Easily, because once I get up a little bit over 100 kilometers an hour, then with the way my car is currently tuned, we're going to a double skid. As long as I'm not ridiculous. Interesting. All right, let's see if we can get up to 150 and then hit hard left. There we go. That'll roll it. And why not? That's not unreasonable. If you're going 150 kilometers an hour and you crank your steering wheel as far as you can, maybe your car should flip over. I feel like I got a pretty good set of balance right over here. Anyway, I hope you enjoyed this quick little video. And again, you can download the project down below. See you next time, folks. Bye-bye.